Recording in progress.
My history and STEM blend lesson covers the history of credit cards and the Luhn algorithm. The lesson is designed for an AP computer science class, and it addresses the two standards listed below, which are the use of flowcharts and a pseudocode to design and illustrate algorithms that solve complex problems, and the standard to demonstrate ways a given algorithm applies to problems across disciplines. So the Luhn algorithm is used to validate credit card numbers, and it's a very impactful and powerful algorithm used to validate credit card numbers and a variety of identification numbers, and it's fairly accessible to computer science students. And the history of credit cards reveals that the Luhn algorithm, along with other technological innovations that happened around the same time, informed the standards that helped credit cards become as we know them today. And through this lesson, students can understand this history, the importance of these standards, and how a simple algorithm that they can replicate in this lesson is able to empower online retailers and influences many aspects of society. And it allows students to practice a variety of computer science skills that will be evaluated on the AP exam, assigning variables, Boolean expressions, conditionals, lists, and mathematical expressions in Python or any other program language you could use for this lesson. This is like a brief infographic demonstrating the history the lesson will cover. Essentially, credit cards used to only be able to be used for specific retailers, used locally. And in 1954, the Luhn algorithm was created. And along with that, the invention of magnetic strips. Both of these inventions were incorporated into modern day credit card standards that are used across different credit card companies. So all credit cards today have a magnetic strip still, and now there's other ways, but when they all follow a certain number system so they can be validated. And I'm going to talk about the technical standards for credit cards in the lesson, how there's different aspects that have different meanings, and the validator digit is what is used in the Luhn algorithm. So essentially, all the digits prior to the validator digit are combined in a specific way using modular arithmetic, and then they should come out to equal the validator digit. And if they don't, it's an invalid credit card number. So I'm going to provide some scaffolding to help students run through the Luhn algorithm by hand to determine if a credit card number is valid. And then they're going to develop pseudocode, and then they're going to write Python code, a Python function to run the Luhn algorithm and determine the validity of a variety of credit card numbers. And then they're going to try and do randomly generated ones and see if their Luhn algorithm is able to detect it, and also see if their Luhn algorithm is able to detect typos. We're going to conclude our discussion talking about how other applications of the Luhn algorithm and how this standard can be applied not just to credit card numbers, but it's used for Canadian Social Security card numbers, for instance, and just re-emphasizing the importance of standards for interoperability.